Hi all, I'm here to talk about graphing parabolas. So on the left we have a parabola we're being asked to graph, and it's f of x is equal to 2 times x minus 4 squared plus 3. Okay, if we open the question help and the view and example, we'll see that the book, in most instructional videos, will give us these tricks for figuring out what we're supposed to do. So they write this general form, a times x minus h squared plus k. So the vertex is hk, and we notice that a is positive and large, so it's going to go open wide and positive. Open, narrow, and positive, sorry. And just like I did right now, these are easy to confuse, and a lot of students find it more confusing than helpful to try and relate everything back to this form, because this trick, if you will, only works to memorize what the layout is, only works if it's written in this form. So I want to go back to basics and say that it's never wrong to just make a table of values if we don't know where to start. So for this, I would do my good old-fashioned XY table. And if I just have no idea where to start, I'm going to start by picking the easiest values I can think of and see if it gives me a pattern. So 0 is always easy to work with, 1 is easy to work with, and then I'm just going to stay small, and I'll throw in a -1 and just see what happens for these values. All right, so if I plug in 0 up here, then I'm going to get 2 times 0 minus 4 is -4. -4 squared is 16. So 16 times 2 is 32, plus 3 is 35. So let's just write all that down right after I find the undo button. There it is. So this is 2 times 0 minus 4 squared plus 3. And so this doesn't require us to memorize a form or understand what the form is giving us, but it does require us to do some order of operations work. So 0 minus 4 is still -4, so I have 2 minus 4 squared, and I'm doing this with a mouse, so you'll have to forgive the terrible penmanship. And -4 squared, I square the 4 and I square the negative, so it goes away, so that's 2 times a positive 16. 16 plus 3. I'm going to run out of room. 2 times 16 is 32, plus 3 is 35. So I'm going to follow in that same manner here. It would be 2, 1 minus 4 squared plus 3. So again, we're taking the value over here that we chose for x, and we're plugging it in for x in the equation. So we choose values, any values you want, and if you have no idea where to start, then choose the values that will be easiest to work with in your equation. And I'm going to say this is 2 minus 1 times 1 minus 4, so I'll write this one out, and then after this we'll just start filling out the table. So 2, positive 1 minus 4, that's -3, squared plus 3. So -3 squared, we square the negative and we square the 3, so it becomes a positive 9 times 2 is 18 plus 3. So that is 21. All right, so now maybe using a calculator or some sort of program. I use Excel when I have to do a lot of things repeatedly. I will just fill out the rest of the table. So 2 would give me 11, and -1 would give me 53. So looking at this pattern, I'm just going to move over somehow. Okay. It looks like I have just a very rough graph here. 0 would give me a positive 35, so I'm up really high. 1 would give me a little bit lower, so it looks like maybe my parabola is going this way. 2 would give me, a little bit lower again, and -1 would go really high, even higher than 0. So yeah, it looks like my parabola is going to go this way. I just have to figure out where this bottom part's going to be. So what I want to do is plug in more positive numbers, since I know the parabola is moving this direction, until I can find some repeating values. So I want to find where it bottoms out, and I'll know that I found that if I can repeat this value over here. So let's go plug in some positive numbers. So I'm moving this direction. 2 is as far as I've gone, so far. So I'm going to start 3, and then 4, and then 5, and see if I can repeat back to this 2 value. Alrighty, where'd that hand go? This guy, and that. Alright, so 2, so next would be 3, and then I'll try 4, and 5, and I'll just see if I can get any repeats back to that 11. Or at least start moving back up. So I just want to find a bottom somewhere. Alrighty, so let's see. If I plug in 3, I will get 5. If I plug in 4, I will get 3. And if I plug in 5, I will get 5 again. So look at this. I have my repeating values, which tells me that this is likely the vertex. And now that I've done this table, I can go back to my problem and see, well, can I recognize this in the form that they gave me? And it looks like, oh, sorry, I based it on the original problem over here. And it looks like, yeah, I can recognize this in the form that they gave me. There's my 4 and there's my 3. So it looks like this part of my vertex is on the right track. All right, so I'm going to go over, because it's too hard to do this with the mouse, I'm going to go over to an actual grapher and show you the points that we found. So we found 0, 1, and I've got some extras on here. We didn't find this. Oops. We didn't do this. And we didn't do this one. We did do 3 and 5. Do I have 3 and 5 on here? Yes. All right, so these are the actual points plotted accurately, the big green points that you see over here. This is what it would actually look like. And if we plot on the actual graph, we can see that we were in fact correct. So I just don't want us to leave behind the basic methods that we have, which is a table will always work. And we can plug and chug in that table and try and build out our graph. So remember, we started with values that were easy to work with, and we graphed those few values and looked for a pattern. And the pattern that we found over here was over on these dots, right here. This was a pattern we found, and so we guessed from this pattern right here that our parabola is moving this direction, and then we just kept plugging in values until we found some that repeated. And when it repeated on the back and front, so of 4, so behind 4 at 3 and in front of 4 at 5, we thought maybe this is a vertex, and we went over and confirmed in our equation that we could find numbers that represented 4, 3. All right, I hope this method is helpful for you. There's more than one way to graph anything. And again, the examples will come with these quick tricks. If I can change the way my parabola looks to this form and memorize these pieces of information, then yes, I can graph it faster. But it doesn't mean I can't graph it if I don't have that memorized or don't understand how that form works.